Hi guys, this is Matt with MonsterVR, bringing you another C# lesson. I'm going through this book called Learning C# Programming with Unity 3D. It's by Alex Okita. It's a good book. Highly recommend you pick it up. All I'm doing is picking out little functions and projects that they have here. Really basic stuff, but just to get not only my learning going, but your guys' learning as well. So maybe I'll just jump into it. So I created a script called mat function, and we're going to talk about functions today. So let's get to it. So a function. Writing a function. A function consists of a declaration and a body. Some programmers like to call these methods, but some semantics aside, a function is basically a container for a collection of statements. A basic example. So we're just going to take this. I'll just get rid of it for now. We can always bring those back. And we're just going to create a function called void my function. Misspelled it. There we go. We're going to do our parentheses and opening brackets. Every time we write a function, that needs to happen every time, I think. So we'll just make it, actually, bring that back. There we go. This is what I meant to do. Boom. Bring that down there. Perfect. Alright. So, here's a basic function called myFunction. We can add in additional keywords to modify the function's visibility. One common modifier we'll be seeing soon is public. We'll get further into the public keyword, blah blah blah. So, we're just going to make this a public function by putting public in front of it. Boop. I don't know. Oh wait a minute. I don't know why that's there. We don't need that. There we go. And we'll just tab in and tab in. Perfect. There we go. That looks better. All right. Cool. The public keyword needs to appear before the return type of the function. In this case, it's void, which means that the function doesn't return anything. Return types are something else that we will get into, but functions can act as a value in a few different ways. For reference, a function that returns an integer would look like this. A return statement of some kind must always be present in a function that has a return type. So, if we wanted to return an integer, we would turn this void into int, bam, and we just put a statement here. Return 1. Nope. Return 1. Okay. Alright. The public modifier isn't always necessary unless you need to make this function available to other classes. If this point doesn't make sense, it will soon. The last part of this function is always required is a parameter list. It's valid to leave it empty, but to get a feeling of what an argument or argument in the parameter list looks like, move on to the next example. So, what we could do is go back to here and go void, and then right here we're going to pass it an argument. We're going to pass it integer I. Boom. Alright. For the moment, we'll hold off using the parameter list, but it's important to know what you're looking at later so it doesn't come as a surprise. Parameter lists are used to pass information from outside of the function to the inside of the function. This is how classes are able to send information from one to another. We've been passing an argument for a while now using the debug class. The log member function of the debug class takes a single argument in debug.log, parentheses start. The start is an argument we've been sending to the log function. The debug class is located in the Unity engine library and made available because using Unity engine, which is right here. So because of this, we're allowed to use the Unity engine library. We'll see how to use these different parts of a function work as we get to them. Functions are versatile but require to set up. Luckily, code is easy to build up one line at a time. It's good to know that very few people are capable of writing more than a few lines of code at a time before testing them. To use a function, you simply enter the identifier followed by its argument list. So, we're going to create a new function. We're going to get rid of this one. And we're going to go void simple function. There we go. Boom. Boom. Perfect. All right. And what we're going to do is we're going to go debug.log. Oh, misspelled that. Simple I need to put quotes. Simple function is being called. Perfect. Go here. Bam. And put a semicolon to end in the line. Then we'll bring back our void start function. And we'll put simple function. Alright. I say we run this. Let's hit Control S. And let's put this script on the main camera, shall we? Just throw it on there. We'll go to the console. We'll hit play. Bam! Simple function is being called. So our function is being called in the console. So that means it's working. Perfect. Perfect. Let's go back to the code. Alright. The placement of simple function method in the class has no effect on how it's called. For the sake of argument, we can use simple function method anywhere in the class as long as it's being declared at the class scope. Void start, simple function method. Yeah, you could do it completely backwards. We could have the void start up front. We could have this up top of this. It doesn't matter. It's the same thing. Here we've used simple function before it was declared. You may have noticed that debug.log looks similar to our simple function. Print, blah, blah, blah. Okay, perfect. All right. We are going to do a new function here. All right. So let's get rid of this. We'll close out my behavior or the map function class, and we're gonna go void my function So, so first we're gonna go integer I is equal to, whoa, what happened there? That was weird. My function. Boom, 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 boom. Perfect. Alright. So now we are going to int I is equal to 0. And then we're going to go, we're going to throw a while loop in there. Alright. This is like in advanced stuff. While. We'll get to while loops later. So we go while. What's happening here? There we go. Parsing here. Alright. So we'll go 10, 0, bam. 0, bam. Perfect. Okay. And then we're going to hit this up again. Perfect. Alright. And what we're going to do is we're going to go print I and then we're going to take I and add 1 to it. Boom. Alright. So my function runs this up, and then we'll go start function. So we'll go void start. And we'll just run my function in the start function and see what happens. Shit. My function. Boom, boom. Boom. Perfect. My function, blah, 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 while loop, I plus plus. All right. So, the contents of a while statement inside of the function are tabbed over twice as indicated by the arrows. Presentation helps to clarify that the contents of the while statement are executed differently from the rest of the function. So, as you can see, the while function is in the actual function here. So, we're running a function within a function. And, or it's a statement actually, it's not a function, excuse me. To help understand how the previous code fragment read by the computer, we will step through the code one line at a time. Blah, blah, blah. Okay. Let's just take a look at this. So the first line, void my function, is identified by the computer. Void my function is identified by the computer and is used to locate the code to execute. Once the function is started, the contents of the code begin at the first statement. In this case, we reach tab over once, which is a comment ignored by the computer. I didn't put that in there because it was a comment. We reach integer I is equal to 0, which is a declaration and assignment of a variable that is identified as I, and an identifier commonly used for integers. This declaration tells the computer to create a small place in memory for an integer value and is told that we're going to use 1 to locate that data. Or use I. Following the variable declaration, we get to another comment that also is ignored by the computer. Yeah, I didn't write it in there. The while statement, I is less than 10 line of code follows the comment, and this opens another space in memory for some operations. This also creates a connection to the I variable to check if the while statement will execute. If I is a value less than 10, then the contents will be executed. Otherwise, the contents of the while statement are ignored. Another important character the computer finds is the open curly braces, which is right here. This guy and this guy. That tells to recognize a new content for execution. The computer will read and execute each line in the while statement till it finds a closing curly brace, which is right here. Boop. Closing curly brace. In this new context, we will return to the first curly brace until the while statement's condition is false. Because I is less than 10, the while statement condition is true, so we will proceed the first line of the while statement. In this case, it is a comment that is ignored. This is followed by a print function right here, print I, which also has a connection to the I variable. Therefore, this line prints to the console the value which is being stored at I. Once the value has been printed to the console, the computer moves to the next line down, new value back to I. This means that the new value for I is 1 since we started at 0. Once the computer reaches the closing curly brace, we jump back to the top of the while statement. The contents of the curly braces are repeated until the value for 1 reaches 10. Once the iteration returns 11, the condition of the while statement changes from true to false. Because 11 is not less than 10, the statements found between the curly braces will not be read. Therefore, the code in the while statement will be skipped. Once the computer reaches the closing curly braces of my function, the computer stops running the function. Computers do exactly what they're told and nothing more. The compiler runs using very explicit rules which it adheres to adamantly. Because of this, any strange behavior which you might attribute to a bug should point to how you've written your code. In many cases, small syntactical errors led to errors which the computer will not be able to interpret. It's greatly up to you to ensure that all your code adheres to a format that the computer can understand. When you write in English, a great deal of the sentiment and thought you put into the words can be interpreted by each reader differently. For a computer, there's only one way to interpret your code, so either it works or it doesn't. So, I say we hit Control S and hit play and see what happens. We'll hit clear. Bam! Look at that. 1 through 10, or actually went to 9, and then it stopped because it didn't work anymore. Perfect. Awesome. So that is our function. Cool. What we learned? Function declaration is similar to class declarations. Functions are the meat of where logic is done to handle variables. How variables make their way into and out of a function is covered in section 6, whatever. There are many different ways to handle this, but we will have to handle them one at a time. On your own experiment with functions like the following. Alright. Anyway. Thank you for watching. I'm going to keep running with this. See where this thing goes. Stay tuned tomorrow for when we get into order of operations. I think that'll be a good second chapter. Perfect. Until then, once again, my name is Matt of MonsterVR. Thank you for watching. Hope you have an awesome day. See ya. Hi guys, this is Matt with MonsterVR.